Okay, can you hear me? Yes, you can. Okay, so welcome back. So in the afternoon session, we are going to have 4 talks. Yeah, okay. So, and we have 4 speakers, 4 talks, and all 4 of them have completely different career path. So what we would like to see their experiences, what opportunities they have, what options they had, and what path they have chosen. And we would like to learn from that. For example, Marc had almost all academic career. Radhika did her PhD, went to industry, and then now went back to funding organization. We had Chidem. She did her PhD, did some work in the industry, came back to academia, went back to industry, came back to academia. So, and we have Zaki, who did her PhD, his PhD, and then started a startup. So, and then afterwards we'll have a panel having all 4 of them. I'll moderate the panel, and we'll be able to ask questions and have different perspectives. So that's the purpose of this afternoon session. With that, I would like to invite Professor Marc Hanheide for his talk. Sorry.
Thank you very much. How do I get to my slides?
Yes. So
we did the adventurous thing, so we copied it over from my Mac, and now we will all see together whether it actually works. Cool. There was a clicker before. Oh, there it is. Excellent. Cool. Well, welcome everybody. I was invited to talk a little bit about my academic career. Bit of a disclaimer, I didn't start completely in academia. I was a software developer for Panasonic and a small subsidiary of that at the beginning. And before that, I was a hospital nurse. And that has actually helped some of the early projects that I was working on. Now, at the moment, I'm at the University of Lincoln, where I lead the Center for Autonomous Systems and also the Agri-Forward CET. So this is the Center for Doctoral Training in Agri-Food Robotics. What I'm going to start off with, the big photo, big group, lots of different interests in there. The bulk of what we do at the moment is really in, no, you can't point here, no. It's in agri-food, that's our biggest area, but that has evolved over time. So when we started this center, I joined Lincoln in 2012, we had no agriculture. That really only kicked off in sort of since 16, roughly, I would say. And that's the first sort of thing. Sometimes you need to grasp opportunities as they emerge, right? If you're in Lincoln, all of a sudden you realize you're surrounded by lots of fields and companies in that domain. So this is the whole group. Some people, Athanasius is also here. I'm not going to talk too much about that. My journey, academic journey, let's say. So I was at the University of Bielefeld, did my PhD there. That's what's in brackets. That was actually nothing to do with robotics. It was augmented reality. That's what augmented reality looked like in 2008. Oh, 2006 actually it was. And then you see some sort of different robots going through. And I think my take-home message to most of those younger ones is you want to have a theme that keeps you going, right? And that is not necessarily an application domain. So for me, it's not agri-robotics. I'm excited about it, but that can come and go, right? It's very trendy at the moment, lots of funding in it, very good. But it's not necessarily what keeps me going as a sort of main interesting aspect. So ever since I was interested in robots that are useful, I'm not so much a developmental robotics person. I want them to have some innate ability, some common sense, let's call it, and they must adapt. And then the big thing that I'm interested in is getting robots out into the wild and having them working reliably over long timescales. Somebody I talked to very briefly early on. This was mainly driven by my initial sort of involvement in European projects where I was in charge of the system integration. And we put lots of effort into building robots to showcase them to our reviewers for 10 minutes. We worked our A off for 2 weeks to just show like, oh yeah, it works. And then it couldn't get used anymore. And that's really frustrating in academia. And that also is what kind of often stops you from making the step to industry and make real impact, right? If you just make something that works now, so this sort of classical, oh, it worked yesterday. and it never works again. So I'm very much interested in sustainability of actually academic progress, let's say, right? And those people who work with me know this often comes with a lot of, me cracking the whip on putting our stuff on GitHub, making it reproducible, making sure that we have got certain software standards. I see some nods there. Some people have suffered with me through some of this. Good, cool. So, then the sort of key enabler project for that, and I'm going to talk a little bit about the science behind it, was that we want to really have, see, there's the first problem by transferring it to Windows, is that once we have got some sort of robust behavior, we can achieve long run times. That gives us opportunity to learn in time, right? Gives us new opportunities to learn something and change the robot's behavior, and hopefully exploit that stuff we have learned to improve performance, get even better, longer run times, fewer interventions, and therefore we can learn more. Right? So kind of lifelong learning adaptation is something that kept me going, and mainly with sort of main contributions, if you look at publications, it's sort of in machine learning, artificial intelligence, and a lot in human-robot interactions, because one of the best knowledge sources you have in the world are humans around you. And you'll see, I'll give you some examples of how you can actually exploit humans in the wild when you encounter them and not having them specifically come into your lab to train robots. So I give you 3 quick run-throughs, and this is all very superficial. I'm just going to give you a flavor of what gets me excited. This was in care, so like me, a background nurse initially. Care home in Austria. We had this robot, couldn't do very much, didn't have any arms. But we used it there as part of a European project called Strands to learn in the wild. So this robot was 1,000 miles away from us. It ran autonomously and provided, among other things, information services to the residents of this care home. And the whole thing was, can we actually get better on the fly, right? Can we learn from something from the experience of being there? In a very simple way. And so, all the people could do was click something, see the menu, see some entertainment, news, etc. And what we observed very quickly in human-populated environments, obviously we all know the world isn't static, but what we discovered is it's very much full of routines. Right? We all tend to do the same things at the same time regularly, because we need to eat, we need to sleep, we have work days and weekends, etc. So one of the initial ideas there, how can we probably learn things relatively quickly without doing massive amount of data, by putting a very strong model in place, namely the assumption that things happen periodically. And to basically, for this stupid robot to deliver better services, it was just, where is the robot when? Where should it be to be most useful? So it's a utility optimization here. And did people use it? So input, simple machine learning problem in that sense. We know where the robot is and when it was. And did people actually use it? So we recorded people clicked stuff on the screen. And the main idea for us was that we had designated this whole wing. It moved autonomously, etc. We weren't there. Nobody was an experimenter. This robot was there, left on its own. And that's what gets me excited. And we developed something that we exploited in many, many different domains that we call frequency map enhancement. The simple idea is, whatever you do, use a Fourier transform to model it, right? Because you've got good theories about sampling theory. You can sample relatively coarsely to still recover some of the fundamental frequencies. And so we just modeled whether people will use this robot in various places and then basically send it there. So very simple approach. And these are the sort of main results. So most popular was the robot, the most successful was near the lifts. So that was where the robot actually was most used. And then you see that this Friseur too, so sorry for the German words in here, that one was actually a very unsuccessful point. The designers of the system that we did there in the care home, they designated this point initially, but then they actually changed the layout, and this point was basically behind a plant, and nobody could really reach the robot. But it learned that, right? So it basically had learned that it is not very useful to go to this place. Cool. And what we see is an overall significant upward trend of use. And that's, if anyone does human-robot interaction, that's kind of contrary to the usual thing that you get, where we have a novelty effect and people lose interest over time. So we got the numbers of interactions up over this range of 80 days that we analyzed. The robot was there in total for about a year. Cool, so that's my other key job. A key phrase here is getting better on the job. I'm interested in robots that get better on the job. And this thing we carried on. So different scenario, similar idea, similar robot, we put it in a museum. It's probably one of the longest continuous deployments, slightly interrupted by COVID. Poor PhD student Francesco over there who had to deal with that. That was really a PhD student who could credibly claim that his work was massively impacted because it was a robot in a public space and there was no humans to learn from anymore. But general idea we've had this about, and it does tours to visitors. Initially it was designed tours by the educational team of that museum. It's an archaeological museum in Lincoln, and they had 4 different tours designated that they thought people might be interested in taking, and the robot takes them around, tells them about it, has different levels of how much detail and what sort of how technical language it uses to explain all these artifacts. And that we can call the action space, right? The robot had initially very simple, we do this tour, we go here, and then people could say on the screen, oh, I want to know more, I don't want to know more. But that was a sort of action space we thought we could explore to learn better tours, potentially. So what we want to do is to do some reinforcement learning in the wild. So directly getting something from the visitors and learn, in the end, better tours. More engaging tours, people that stay on longer, we get more information across to them. And the key bit that we first need, for anyone who does reinforcement learning, we need some reward, right? We need some sort of reward, wherever it comes from. And we can't have this, oh yeah, you fill a survey afterwards. We didn't want to do that, right? It should learn from the experience. So first work was to get some sort of reward. And we did a, almost classic end-to-end learning of video images of the camera see from the robots with people around them, and map that, do a regression onto a feature, just a scalar between 0 and 1, where 1 is fully engaged, 0 is nothing. And we had got a number of people to really just watch this video at high speeds that we got them as training material, and they had a slider. They just moved the slider while they were watching this. Are these people engaged? Are they not engaged? Based on the assumption that we humans are pretty good, right? I can see when I look around that there are some people who are behind their laptops and not particularly engaged, and then there's others who pay proper attention. So we have an intuitive understanding of that. And there's, in psychology, you find lots of cool models about how you can model attention, engagement through kind of gaze recognition, etc. So now, let's work on the assumption that we can somehow do this. So, and it works surprisingly well, right? We got a good inter-rate agreement between the humans, so the humans had an intuitive understanding of it, and our regression achieved quite good results. So we took that as a reward, put it onto our robot, say, like we know, we do some end-to-end getting a reward signal. Action space was, where can the robot go in the museum? How much can it tell about the artifacts? And can we just do in situ reinforcement learning there without any specific coded reward other than that? And yeah, I have to say I'm very pleased that it kind of worked as well. Lots of results on this slide. The main message is the sort of going up where we have got the learning area. So this is only a few sample points plotted on here from these many days that it was there. And we can see that it actually ended up delivering better tours, or tours that were that people stayed on with for longer, stayed until the end, right? By adjusting how much information was given and which order the artifacts were explored to. So in a way, that's again another example of getting better on the job in such an environment. And I'm going to quickly go into what is my main focus at the moment, is robotics. We have got a lot of work in that domain. So in our agriculture campus in Riceholm, you get some of these ideas, a beautiful landscape overall, where we have got trial fields, we have got a strawberry farm, we've got a vineyard, and that's all the interesting domains for us to explore. And my main focus is making robots move reliably in there and safely and interacting with people, right? And again, that is something where kind of keep going the same theme. I want to make sure that they can cope with change. And temporal change is something, as you may have noticed now, I'm very excited about. And temporal change happens in agriculture a lot, right? We have seasons. and the world changes massively. Everything looks the same if you're in one moment in time and you walk around an orchard, a strawberry tunnel, whatever, almost everything looks the same. So it's terrible from a robotics perspective in perceptual aliasing. Temporally, however, it changes a lot. You map it one day, you come back the next day, or 2 days later, the weather has changed, the crops have grown or have been harvested, they're completely gone, and you need to be able to deal with that sort of change. Good. And you see we do lots of different aspects in there, and you see quite a few of my colleagues in here. Now, again, I'm going to pick one example relatively quickly. This is from a data set that's publicly available. I think it's a nice, interesting, challenging one, taken from a vineyard in Greece, part of a European project called Bacchus that has just ended. And you see the sort of data, that's our data recording platform that we had there that autonomously went around. And that's the picture from March. That's what wines look like in March. And that's what they look like in June. And there's another one where it's in, in September, where it is like really lots of leaves there. And that's an interesting data set that also those who were in the Agri-Forward session have quickly seen how people use that in mapping. And because we have so much change over time, RTK GPS isn't really the answer for all these kind of relatively challenging environments where often you have GPS-denied areas. We looked at how can we localize more reliably in there, because generally everything looks the same, and the bits, most of the bits that you see change a lot from one week to the other. So we were trying to think whether we could actually get better performance by filtering our maps, filtering our sensors. Right? And the main underpinning idea for that is we again use the temporal information. And we don't annotate any of the data. We just go, well, that looks very crap up there. Anyway, we basically map the same environment many, many times. So we gather the data many, many times, register those maps on top of one another, and then can get basically an unsupervised labeling out of that, because we can see where changes happen. Right? That's the different stacks, same environment at different time scales, and you get an idea for each point, if you want, like a 3D point, how far away is it from time slice 1 to time slice 2? What's the nearest neighbor? So it's a bit like iterative closest point over time. And that gives us what we can call a stability feature. Right? So that's the data label. We haven't done any manual annotation. In that sense, there isn't any ground truth. The ground truth is over time being in the same environment. And use that as the main input for then doing some learning on top of that. All right. And if we do that, the really cool thing is, so we could have done what a lot of people do is like semantic segmentation, right? Explicitly model that, for instance, tree trunks are pretty static. Leaves are not static, right? Or you could say walls of buildings are pretty static. Canopies of trees are probably not. So we didn't do any semantic segmentation in that sense. It was all purely data-driven through temporal stacks of maps. But what you get from that is actually that you can learn stable point segmentation. And it's quite interesting that we just trained this in this data set from this vineyard, and it develops an understanding of what generally static features can look like. So, I'm not going to bore you with all the like big paper in RAL that came out very recently, where ours is doing pretty well. The key thing is that it generalized well. That's the really exciting bit. I'm going to show you this. So BLT is our data set. That's the one that was trained. And then we did this segmentation also in Mulrun and the North Campus long-term data set, where it actually works really, really well. Filtering out, for instance, cars and filtering out canopies in street scenes, etc. So purely trained, no actual semantic classes, just what makes it stable. And in all of these data sets, even they're a completely different domain, not agriculture, it improved the localization by filtering out all the stuff that changes from one, to over time, focusing on the stable bits. Good. All right. So that was a very quick run through my sort of stuff that gets me excited. Now comes a few photos I'm going to share with you, and hopefully a few lessons that I find useful. I'm just going to tell you whether you find them useful or not. You need to decide yourself. So lots of photos, right? Starting off from PhD, good tradition in Germany. You get a crafted head from your department. Very early started organizing summer schools or winter schools with good people. Moved on to, the academic system in Germany is strange. You can't make an academic career in Germany if you haven't been abroad, which leads to a massive brain drain in Germany because eventually people decide, oh, actually this place isn't that bad either, which is what happened to me. Initially, I left Germany to get experience with the whole aim to go back, right? Just get 2 years postdoc experience in Birmingham and then come back. But then I met this guy, Tom Duckett, who was a reader at Lincoln at the time, actually, and we invite, because some of these people you may know, that's Nick Horse, who's now the director of Oxford Robotics Institute. I worked with him in Birmingham, and we had the idea of making a European proposal together. And then we looked for people who do long-term autonomy, and then we came across this guy, Tom Duckett, and invited him over for a research seminar. So again, like something you need to do, right? If you find some people interesting, invite them to give a talk in your department. That's how you make contacts. And, well, he said, oh, yeah, we've got a job open if you want to apply. I thought, yeah, I can try, right? Because the other thing, German system, again, very strange. You probably know this, right? You need to have a habilitation unless you are an academic already somewhere abroad. Then you can waive that requirement. So I didn't want to write another write-only thesis that nobody's ever going to read, really. So I decided, oh, that's not a bad idea. I'll do that for another year or so, right? And that's how I ended up in Lincoln. And going then forward, we won this European project. That was Strands. We started the group, Tom and I together at that time, and built it up, and then we did RoboCup competitions. I can also recommend those. Did a few trips to, go for sabbaticals, brief ones. Been to Sapienza, been to Bonn, been to Gran Canaria. I can only recommend that one. It's really about getting out there. Good. Right, so I think what is important from sort of a rewarding academic career, I wouldn't say successful, let's say rewarding, right? What makes me excited is to have a sort of long-term agenda, to have a sort of problem that you can go back to. If you don't know what to do, at least you can say, oh, you know what, I'm going to look at this sort of temporal problem from a slightly different angle again. So I think that's something that has really, really helped me a lot, right? Because you can frame a lot of problems from that perspective. And from that come, more and more things. And you're not tied to one methodology. I've seen so many methodologies of machine learning come and go. Right? I can't keep up with all of them. But the sort of general problem is something that I can still define. It probably will keep me going for another, how long do I have left? 20 years or something. Yeah? Network, really important. So what you do here, so you may have seen some of these old faces. Almost all the people that were relevant to my career, and there's people that were really influential and really important, I met at conferences like this, right? At nights out. Don't sit in your hotel room, go out. Even if you don't drink, make sure you mingle. You will. Okay? I have to say, drinking helps sometimes, but it's... many of successful academics are social beings. There's exceptions. Some people are just brilliant in their own mind. It's not the only route, but I think for many, collaboration, at least for me, collaboration is absolutely essential. Go visit places. Keep exploring. Keep hacking. Invite everybody to have a bit of a look at my GitHub profile. I'm still trying to play around with stuff. I do much more code reviews these days than I actually do generate original code. But, whenever I have a chance, like my own personal sabbatical is a week of hacking and trying something out. Even is it for this, so during the summer school, I've also been playing around with some of the bits there. And as I said, the key bit that what this enables me to do is to ensure that we have got a somewhat stable software stack. That we don't have to start from scratch again. We build on top of things. Yeah, sometimes that carries a lot of legacy that people would rather get rid of. Right, James? I think it's also important, in particular in academia, is that you need to talk, you need to present, you need to go out and talk about what you're doing. You are very much, I always say academia is being self-employed within a franchise. Because in the end, I work for the franchise of University of Lincoln, but a lot of the stuff I do is very much being self-employed. Right? You run your own dissemination, you run your own bookkeeping, everything. Really important is to enjoy and celebrate particular success of others that you have mentored along the way. Just some photos here where I'm particularly proud of what people went to do. Also, I would say teaching is not a burden. It's often perceived as one. It's really important to develop yourself, and particularly important to spot talent early. Like how many of my best students come from some undergraduate involvement? I say, oh, no, that's good. Why are you interested in doing this? So that's it. And really kind of work on real-world problems. It's much more rewarding. I think that's the key part, right? It's good to do that, but I find it also much more rewarding to work on real-world problems with industry partners and get out of the lab. Cool. So you are everything. If you come through academia and you go for an academic career, you're everything. You're a researcher, teacher, accountant, HR assessor, immigration advisor, business, whatever. You have everything, and you are mediocre in all of them. That's it. Thank you.
Thank you very much. Thank you very much for the fantastic talk. So we have time for one quick question, and then obviously we'll have the panel discussion, so you will have plenty time to ask questions. So one quick question if you have any. Any question? No? So we, okay. So we'll go to the next presenter, Radhika.